Welcome to today's lecture, where we are going to talk about the connection to the database. Last time we did a create, read, update, delete on a certain model that was a roller coaster. And today we're gonna do something else, try it out with some different models, but connect them to the database. And this video is about code first connection to the database, so let's do that. And upcoming video is going to be database first approach. So let's get to it. So let's start by creating our new project. I don't want this. Let's see. So creating a web API. Let this be called GameDevs. Let us use that theme for today. So .NET 8 and everything is as it was before. We create one and let's get rid of, let's see, what is this? So let's delete the stuff that we don't need. We don't need a weather forecast model and a weather forecast controller. And let's start doing the stuff that we need to do. So as this is the code first approach, we need to create our models and specify our relations, right? So let me explain the flow. The flow is, I can maybe draw. So if we go here, let's draw something. So these are our models, right? So we have 3 models and they are going to be called GameDeveloper. So one is a game developer, the other will be projects that the game developer does, and the last one will be technologies that are used in those projects. So this is our C# code, right? So what we have here is C# code. So that is the code first. From code, we want to do what? We want to build database tables, right? So that's what we're going to do. So building both the database and the tables with all of the attributes that these 3 have, right? So in order for us to get there, we need to do something, right? Because we cannot write C# code directly into the SQL database, right? So what we do is that we, with help of not something, but a package called entity framework, what we are going to do is that we are going to take this C# code, we're going to transform it, compile it, transpile it, however you want to format that however you want to call it. So transpile, transformat, rewrite C# code to SQL database with help of this. So it goes from the C# code, and what we're going to have is something called a migration. In here you can see what on and how C# is becoming SQL code. So inside here we will have SQL queries that will be used again if you studied databases, or if you know something about SQL databases, you know that we will use SQL queries in order to execute some commands inside the SQL database. So from the C# code, when we run 2 different commands that we're going to show you now, those are pretty easy to remember. So when we run commands that are built into the entity framework, we're going to transform our C# code into the SQL queries that then we're going to run inside our SQL database. So those 2 commands are pretty easy, and if you're using PowerShell or other terminal, they're going to be .NET EF entity framework. So we're going to install this tool inside our PowerShell, or I have it already installed. If you don't have it installed, then you need to write something like this. So .NET tool install global .NET EF. So you're installing a tool inside your PowerShell or your local computer that you can use the .NET EF tool in order to run this type of commands. So this is the command. So let's write, this is a command that you use in order to install Entity Framework tools inside your computer. So if we take this, let's do it like that. So, and two commands that we have. So two commands that we run in order to successfully transform, let's see, to successfully transform the C# code to SQL database is the .NET EF migrations add, and then you have the name of your migration. So this is the first command that you're gonna write in your .NET in your PowerShell terminal, and this one creates, as you can maybe suspect, a migration with the SQL queries, so transformed our C# models into the SQL queries, and then what we write is a simple .NET EF database update. So when we run the second one, then we run this part. So first, of course, is running if we put them together like this. So this is the first one. So running the migration, and this is the second part where we get our database updated. So this is the entire flow, right? So we have our models that are C# code, we have our entity framework package, we have our little two commands that we execute in order to first get a migration with the SQL queries. That will be a folder containing two files, a migration file and a DB snapshot. And then when we execute the second one, .NET EF database update, then we can see how our database is not only being created, but we can see the database tables and all of the properties that we have inside of our models. So this is the entire flow of the entity framework. So let us do that. But before I forget, I wanted to say a big thing that we forgot to mention is that everything happening here, right? So between the C# and the migration and everything and to the database, we need something to connect those two, right? Because we cannot just execute these two commands. We need to know which database we are writing stuff to, right? So we want to know which database we are connected to. And that is something called a connection string. So in whichever database that you have, you will probably have, even if it's front and back end, doesn't matter which framework, you will have a connection string that points into the direction of the server, so where the database exists, what the name of the database is, and as well maybe you have some custom authentication, so we'll have username and password and other types of small attributes that you will need to have in this connection string in order to say that you have the access to that database. So, and that is something pretty important. So connection string. And I'm going to show you how we can get it. So let's start first with the connection string. So if I go to my project and go to app settings from JSON, I will create my connection string here. So I write connection string, and I will say that because this is JSON key value pair, let's say that my database name is Nemo devs db connection string, and the value will be this. So let me just copy paste this. the value will be this. And I will show you why this is. And let's see what I'm missing. I'm missing this one. So first, in this connection string, we have a server. And server is my local that I have here in my SQL Server Management Studio that runs SQL Express. So I have it here, as you can see. Nemo Sensei SQL Express, that is my server. And the database I created, it doesn't have anything, as you see. It's the name of it is GameDevs. So that is here. So I have the server, so I point to the direction where my database lives and what the name of the database is. And this stuff to the right, trusted connection true and trust server certificate, is something that I have on the Windows when I install the SQL Server Management Studio, that I authenticate myself using the Microsoft account or the Windows environment that I have on. And the server certificate is for the TLS secure one. So that's basically that you have. You can have different type of connection strings, and mostly you will have this part exactly the same, and you will have username and password when it comes to how you protect your own database. So here we have the important thing, right? So we have the connection string. So what we need to do now, right, is if we go back to our board, we need to have our models, and then let us install the entity framework with two more packages. So one is entity framework on, and two of those I will show you and explain what they are in order for us to successfully execute these two commands and create our database. So if we go back, let us create some models. So here, let us create a new folder that is called models. And I just want to mention that here, now when we're working with models and database, this is basically a default project when I only want to show you how the stuff works. But once we get into clean architecture, I will show you how we can have a pretty nice view and control over everything that is happening inside a project, and how we can have some nice, well, architecture, right? It's going to be fun, and you can see how easy and understandable it is once we have that kind of separation of concerns into a different type of architecture once we start learning that. But for now, we have only a folder, and let us create our classes, right? Our models. So first one is going to be a game developer, right? So in our game developer is going to have public int ID, right? We can work with GUIDs later on. He has a name. He can have maybe a studio name where he works. And let's directly create the relations, right? Because once we start working with databases, oftentimes you will find that different kind of models have different kind of relationships between each other, right? If you studied the databases, especially the SQL ones. So let's create a collection, and not developer, but this will be a game project. And let's say that these are game projects that one developer can have many game projects, so one to many relations. So we have that here, and then let's create this class in another file. So game project, and what a game project will have is the following. So ID, and let it have a game project title, and let it have a genre. And let's do, or now we specified the relation. So I will say that here I have the game developer ID, and that I have the public game developer relation. And why I do this, I want to show you, because you can have different types of settings and even how you structure your models and your relationships. I could have not written this. Sorry, my Swedish kicking in. So I could have not written this and instead do something later on that I'm going to show you. that actually explicitly says which kind of relation I have between which entity and what are the primary keys, foreign keys, and stuff like that. So I'm going to show you that before we execute those two entity framework commands that actually compile our C# code into SQL queries and execute them. So right now I want to again explicitly both here and in the settings that we're going to build the connection to the database part. I'm going to show you why, and not why, but you already know why it is good to explicitly see these type of relations and connections between different kind of models. And I want to add a new relation here with technologies so that my projects can have different or are built inside different technologies, right? What's this? I don't want this. So, and then let's create this one as well. And the game technology, let's see, I didn't create one. Let's see. Yes, here it is. Nice. So what this will have, it will have only two things. So public int ID, public string name of the technology, and the I collection for the projects, game projects. So nice. So here we created our three models that have relationships between them. Nice, pretty easy. So I want to point out that somewhere you will see that you have this kind of attributes inside of your models or inside a project models that you're working on, if it's work or apprenticeship and stuff like that. So if you see foreign key here, we use data annotation schema. So sometimes you will see that you will have these kind of attributes and then not have anything explicitly said inside of the settings in the database. So not in the database itself, but in the database configuration that will exist in our code. So we're going to create a file that is called app.dbcontext, and I'm going to explain you why. And there we will have certain type of settings that explicitly say which kind of relation each entity has between each other. So what you can see are two different versions, like people writing there in that file explicitly what kind of relation that have, and that is what we are going to do. But you can also find that somebody writes like I showed you here, like foreign key, and specify their relations and everything with the database schema here inside the model on its own. So that's the two different approaches or two different ways that you can see how somebody structures their database schema. But as I said, we're going to do that in a separate file. So let's do that. Let's create our database schema file. So what I'm going to do is create a new folder that is called database, and I will create a new class that is called app.dbcontext. Why app.dbcontext? So when it comes to connecting to the database, oftentimes or most used ways of connecting to the database are entity framework package that we're going to use and something called ado.net or ado.net, however you want to call it. If you have a database heavy project, then most of the people will choose ADO or ADO or however you call it, .NET, because why it is faster is because there you run or you write raw SQL queries, right? So when you're writing SQL queries that are, well, SQL syntax, right? Then they're going to be executed directly into the database. While here with Entity Framework, what we do is we write C# code that then gets transpiled, transformed into SQL queries and then executed into database. And that process, compiling or transforming the code from C# to SQL queries, takes a little bit of time. A little bit of time, but time nonetheless. So that's why if your application is database heavy, like you have millions and millions of different kind of data and users and stuff like that, then most of the people decide to go that way, to execute SQL queries raw instead of writing C# code. And the naming convention while using or Entity Framework is that you name your configuration of your database AppDB context. So you will see that name quite a lot inside a multitude of different projects. So when you start working, if somebody uses Entity Framework, you will see that their database configuration is called AppDB context. But I oftentimes like to say to my students, write or name your methods, variables, files, anything that you will name them something that you understand. That's going to be easy for you to remember, for you to learn, and that if you come back a week or 2 or month or 3 months or 1 year from now, if you come back, that you know what you did here. You know each file and each method and each variable, what it is and what it represents. So that's important. So you can name them whatever you want, but the convention for when using Entity Framework is that you call this one AppDB context. So here we have AppDB context, and I have to inherit a lot of things in order to create a database schema and database settings. I have to inherit a lot from Entity Framework packages. So let us install those ones. So here you see install Entity Framework Core, install package Microsoft Entity Framework Core. So we can do that, or we can do something like this. We can go right click, manage NuGet packages on a project, browse, and then we can write EF. I like to write, but you can also write Microsoft.Entity Framework Core. And here is important to notice this one. You see that you have different versions here. If we double click on our game devs project, you can see that the target framework is .NET 8. When it comes to different kind of packages, then we need to watch out on which version we install, because some of the versions are actually directly connected with which type of .NET framework you're using, and other ones are not. So make sure that you read and especially investigate that part. So as we are using .NET 8, I will install the latest one in 8. So I install this, and I need 2 more packages. One is the Microsoft Entity Framework Core SQL Server. Why? Because this will be my provider, and that's how I can connect to my Microsoft SQL Server that I have on my computer, right? So install this one as well, SQL Server, and then install the design part. And that is the Entity Framework Core tools that help with design time development tasks. They're primarily used to manage migrations and to scaffold the DB context that we're going to use. So let's install that one, 8.0.14. Nice. We installed that. Pretty nice. And then let's go here. So now if I do it like this, I can actually use DB context, and I can do some stuff here. And what I need to do here is the following. I need to first have a constructor, so public app.db context, that is going to have the, exactly, I got it here. So DB context options from here, and or from ourselves, and base that is coming from, this is from the package, and this is coming from the base class that is also coming from the package. So we only have a constructor that, as you see, it takes this, but it inherits everything from base options, and we do not do anything special here. What we need to do here is specify what models we want in our database. So here we say which models do we want to create database tables from. So if I write all three of them here, I will get all of the three tables in my database as well as all the attributes. So let's do that. Public dbset and dbset database set, and I will have GameDeveloper and let this to the right. So this part, that is going to be the table name. So public dbset, and let's do again public dbset, and let's do game projects. Well, we have that one, and then we have, I can copy, and we have what was it, game tech. Yes, game technologies, and let them be called technologies. Nice. So this was all I needed to do in order to get a database table, or when it comes to my database table and the entire database with relations. I need to do that. But once again, let's see, I have an error somewhere. Let's see here, I forgot something. Yeah, I'm missing a, yes. Nice. So be sure to watch your error list. So if I go back then to my AppDB context, I said to you before that you can have those kind of attributes inside of the classes themselves, but what we can do, we can write here, because again, this is a database setting file, so we can do or we can manipulate the onModel creating method that exists inside both the DB context and entity framework core. So we can manipulate that method onModel creating to specify exactly which kind of relation we have between these models, what are the primary and foreign keys, and much more. So in order to save time, let us do a copy paste. So protected override void onModel creating. So I'm writing over or manipulating the onModel creating method that creates all of the tables and the relations and everything. And I say that my entity, or entity is a model, has a one-to-many relation. So I had that one, it has one game developer, many game projects, has foreign key, game developer ID, that I actually also wrote in my here. So I could have specified foreign key here, or even sometimes entity framework can figure this out on its own, but in order for us to not do that and not let the entity framework decide, we explicitly say here how it is going to be structured. And here we have again game project that has many technologies with many projects. So explicitly saying which type of relation do our models have. So this is nice. Let's find the, here is our connection string. Nice, everything is nice. The only thing that we need to do right now is, if I go to program.cs, is to register this service, right? So again, what I need to do, if you remember when we talked about services and dependency injection container, right, is that once we install some packages or we introduce a new kind of service, and especially this one, this is an external service as we are talking to a database that exists in my computer, right, on my computer. So I have to register it somewhere, right? So I have to say that, hey, my application, I'm using a service that is a database, and I would like to have some settings within. And what we do is further, I'm just copy pasting this one, is saying that, hey, builder.services, I would like to add a database, and you use this add db context. That is this one. So it uses the type or the model that is our database setting, right? So it uses this one with options that I want to use the SQL server that we installed as well, right? With the connection string, so the SQL server that will be talking to our database, that, and it uses the get connection string method that actually gets everything or the appropriate part that exists here in app settings to JSON. So it will get this server, this database, and talk to that one. So instead of default connection, mine is called Nemo devs db connection string. So I register a database that is of type this one with options that I use SQL Server talking to my database. So this is what I have to have inside my dependency injection container. So I register this as my service because that is the service that I'm going to be using, right? So the only thing that we need to do now, right? If we go back to our drawing board here, we did the models, we installed the entity framework and those other packages. Now we need to execute these two in order to get our database. So we have connection string, we have our models, we have everything. So let's write here as well that we want, I didn't write that, is the app db context that is going to be db settings file. So let's write that for us not to forget that we need this one as well. So right now we have everything, and now we're going to go to the development PowerShell. And if you don't have the .NET EF, you can test it .NET EF. You can write version. It's going to come back with which version you have. If you write that and you don't get anything, then you can go ahead and execute this one. So .NET tool install -- global .NET EF. So this one will install that tool that you're going to use here. So let's do that. Let's do .NET EF migrations add initial. So I want my migration to be called initial. So the first one, the first command is .NET EF migrations add. So we are adding the migration, right? So let's execute that one. See if it's working. Maybe I forgot something. Yes, build fail. Let's see. Yes, let's try building it. See what. Now it works. Okay. So if we try again, .NET EF migrations add initial, we execute that one. Nice, it says done, and here to the right you can see that we got migrations file, or the entire map. And we see here is our initial with the date stamp, and we have the model snapshot. As you see here, we have a little bit of kind of SQL queries that are going to be executed in the in our table, in our database. So, and here we have the model snapshot, how it looks or how it will look in the database. So we have model builder entity, property, integer, house column type, everything. So you can expect this on your own and see how it actually does the flow from migration or from the C# to migration. So we have this one, nice. Then let's run the other one, .NET EF database update. But before that, let's go here into the database, and if I refresh it, if I go to the game devs, you can see that I don't actually, or this is from, sorry, this is the old one, so let me delete it, or I can delete the entire database actually. And I can create a new one. Let's see, let's create a new one that is game devs, right? So game devs, if I check the connection string, because I did this before, game devs, nice. So if I go here, tables, nothing, but if I execute this one, then you can see that a lot of things happened. And if I go back I refresh and open the tables, I got my models. So developer, project technologies, and game project game technologies joint table. So as you see here. So really nice. Now I can start playing inside my application because I have everything. I have the connection to the database. Now, as I showed you before in the roller coaster application, we can create we can do a create, read, update, delete. And let me show you how we can do that pretty easy and pretty fast. So, Entity Framework, as I said, is not only helping us with database troubles, but it's also helping us with this. Let me show you. So, we need to do a create, read, update, delete on, let's say, GameDeveloper, right? So we need to do a create, read, update, delete on GameDeveloper. If I go to controller, right, and create a new controller, I can do something like this. If I go to API, you can see that I can do a API controller with actions using Entity Framework. So if I click this, add, it will ask me which model do I want to have the create, read, update, delete. Let's choose the game developer. DB context class, right? Our database settings. I choose our app DB context and let the controller name be game developers, right? So if I write add, you will see that it's scaffolding, right? And this is the design part that we installed, the design package. So we'll see now what we get once this controller is made is something pretty nice. So look here. We have our API controller, that is game developer. We have our connection to the database here. So we introduced it here as a dependency. And what I have here is get developer. This is the get request. I get all of the developers from the database. I have database get by ID, right? So get game developer by ID. I have updating, I have creating, and I have delete. So if you want to see how this works, let's run it. So what it did again is it created the entire controller for me and all of the create, read, update, deletes that I needed by using my model, my relations that I specified in the AppDB context database setting, right? So with 2 or 3 clicks, I got all of the create, read, update, deletes. So right now, if we execute, we don't have any, right? So it's probably going to return an empty array. Nice. So let's create one. And as you see, we have a lot of things here. And this actually is a pretty nice way to see if you did something right or wrong. So once we start doing clean architecture and different kind of stuff, you will see that we will work with DTOs and different stuff. Because if we look right here, in order for us to create right now a developer, we need the ID name, studio name, but we need game projects and we need technologies, right? So what this means is that this is tightly coupled and that in order for me to create a developer, I need to also create a game project and also create a technology. So while looking this, I can already say that I don't like this. So I want to change it a little bit. And that I'm going to show you later on once we start working with data transfer objects, DTOs, and as well cleaning up a little bit of this kind of relations, right? So, but let's try something. Let's try it like this. So I can notice here that already this is not going to work because I have an ID of the game developer that I want to create. And here I have game developer ID that is the foreign key. So this would say that I maybe didn't correctly adjusted the relation, but what I can do is I can go to my model and I can go to the game project and I can actually do something like this. I can do a JSON ignore like this and the technology as well here. if I import it here, nice. And now if I start it, so I found out what I did wrong. So when it comes to Entity Framework, you have something that the database, especially SQL database, wants to do itself, and that's set the ID. And instead of me setting the ID here, I can delete it because it will be set automatically inside of the it is auto generated, right? So it's 1 2 3 4 5, so it's going to be auto generated. So instead of me doing it, I can delete it and let the what do you call it, Entity Framework do this instead of me. Or if I want, I can change again. I can come back here and I can go to the let's see where it is, database. I can, in my app.db context here, specify that I want to use my ID and what I set it to instead of it being auto generated. But in order to keep this video short, let's just forget about the IDs and let them be self-generated. And if I write that Nemo is the lead developer and Infinite Code is the studio, game project is new project, and genre is horror, and game developer ID, okay, technologies, .NET. Let's try to execute this one. We have the response body, ID is 2, Nemo, Infinite Code, nice. If we go to the database, if we go to the developer, we can see that we have a ID 2, Nemo, and Infinite Code. So ID was again created automatically as it is auto incremented. But again, I will show you how we can do this setting in the next video once we start with the clean architecture and other stuff. So again, apart from ID that I messed up, that is auto incremented, you can do the entire tutorial the same. You can, if you want, remove the ID or keep it, but not add it inside of the post request. And in order for stuff to be not required, you can set a question mark for them to be not required. That because if you start with a clean database, you will like to ignore this kind of relationships. Or again, you can structure it a different way and create a different kind of setting in order to provide the stuff that you need when it comes to the models that you want to create, DTOs when we start working with them, and similar stuff that we are going to learn later down the path. So this was the part of creating the entire create, read, update, delete controller from the database context that we have with Entity Framework as a package. So that's why it's so simple. But again, as we see now, I didn't structure the relationships correctly, so I get a little bit errors. But you can see, or you will see as we do the database first approach in the next video, how it will look like, especially with the relations and that part that is on model creating. But again, if we go back, you can see that it was not a big hassle. We have our models, we structure our DB context file, and then we install the Entity Framework package and the SQL server as well as design. We do first the migration and then the database update, and we get our database with all of the tables. And for that, we use the Entity Framework that listens to or is talking to our database by using the connection string that is in our app settings.json. So that's how it works. If you have any questions, feel free to comment. I can address them directly, and see you in the next one when it comes to database first approach. Bye.